Good morning, viewers. I am Saraswati, working as a computer science and technology department. I am going to teach about explanation-based learning in the machine learning. What is meant by explanation-based learning? It's a problem-solving method that involves agent learning by analyzing specific situation and connecting them to previously acquired information. Also, the agent apply what he has learned to solve similar issues rather than relying slowly on statistical analysis. The EBL algorithm incorporate logical reasoning and domain knowledge to make predictions and identify patterns. The explanation-based learning system representation. In the representation, there are problem solver, generalizer are there. It takes three kinds of external input. The goal idea is a complex problem statement that the agent must learn. The training instances are a fact that illustrate a specific measure instance of a target idea. The inferences rules reflect the fact and procedure that demonstrate what the learner already understands. Generalizer. The problem solver's output is fed into the generalizer, which compares the problem solver explanation to the knowledge base and output to the operational pruner. Operational pruner. It takes two input, one from generalized and the other from operationally standard. The operational standard describe the final concept and define the format in which the learned concept should be conveyed. Hypothesis. Explanation-based learning hypothesis. If a system has an explanation for how to tackle a comparable problem it faced previously, it will utilize that explanation to handle the current problem more efficiently. This hypothesis founded on the concept that learning via explanation is more successful than learning through instance. It's a standard approach. The typical approach for explanation-based learning in AI entails the following step. First one is determine the problem to be solved. Gather samples of previously solved problem that are comparable to the current problem. Identify the corrections between the previously solved problem and the new problem. The extraction of underlying principle and rules used to solve the previously solved problem. Apply the extractor rules and principles to solve the new problem. Example of a explanation-based learning, medical diagnosis system. It can be used in a medical diagnosis to determine underlying the causes of a patient symptom. Again, trend and produce more accurate diagnosis by analyzing previously diagnosed instance. And next one is a robot navigation. This is an example of a EBL learning. It may be used to educate robots on how to navigate through complicated setting. Explanation-based learning algorithm can discover the rules and principle that were utilized to navigate those settings and apply them to new scenario by analyzing prior successful navigation of effort. Error detection, fraud detection. And the explanation-based learning may be utilized in fraud detection to discover patterns of fraudulent contact. EBS algorithm can find the rules and principles that were utilized to detect prior causes of fraud and apply them to new causes by analyzing previous instance of fraud. How explanation-based learning work? First one is a input example, domain knowledge, explanation generation. Input example. It begins with a single example that the system needs to learn from. The example is typically positive instance of a concept that the system needs to understand. Domain knowledge. It uses the domain knowledge, which include rules, concept, and relationship relevant to the problem domain. The knowledge is crucial for explaining why the example is valid. Explanation generation. The system generates an explanation for why the example satisfies the concept. It's identify the relevant features and the relationship that make the example is a valid instance. Next one is a generalization. Once the explanation is generated, the system generalizes it if it form a broader concept that can apply to other similar example. Generalization typically in the form of rule or set of rules that describe the concept. Learning outcome. The outcome of EBL is a generalized rule or concept that can be applied to a new situation. The system can now use this rule to identify or solve similar patterns. These are the some of the challenges and limitations in EBL. It depends on the domain knowledge, a heavily on accurate and comprehensive domain knowledge. If the domain knowledge is incomplete or incorrect, the system may generate flawed explanation and generalization. It's limited to well-defined problem. EBL is most effective in well-defined problem domain, where the rules and relationships are clear. It may struggle in more complex or ambiguous domain. Complexity of explanation. Generating explanation can be computationally intensive, especially in domain with a complex relationship and a large number of features. Thank you.